Welcome, welcome. Thank you, and welcome so much. I said we're going to start with an energetic beginning. But first of all, you're going to be kicking off. But I thought the whole theme is dream and dare. René, I think a lot of people know that you really are fond of your profession. I mean, everything that has to do with solar panels and organic solar panels and, you know, all these different ways of science that you're actually combining. But there's also this feeling for soccer, René. Even when we were discussing in advance, all the time you were referring to soccer. So what was your dream as a little boy? What did you want to become?
No, as a little boy, I wanted, of course, to be a fireman and a jet pilot. Maybe also a soccer player. That could be right. The reason that I talk a lot about soccer is that it gives quite a few of comparing things with soccer. It's kind of easy in many ways. So I think many people understand soccer in some way, and that you can change difficult topics into something easy like a soccer game.
So, and then what, in a way, went wrong? I was about to say, no, what went well? Because we're very happy with you as a professor, so what happened then?
With my eyes, you cannot be a jet pilot, not at all, not even on the ground floor, basically.
You can say you're a ground floor jet pilot.
A fireman maybe was not strong enough for that. And
how did you become interested in the field you came in later?
Yeah, but by accident, I think. So my feeling for, or I developed an interest in physics and chemistry in high school, and really wanted to know how things work and how things are part. As a young boy, I took apart engines, radios, everything. Never could put them back again, but at least I figured out what was inside. And from that I learned, and that was at some point my passion.
Yeah. And you can eventually win a Spinoza grant with it, which is great. And then, Nick, also in your case, what was your dream as a young boy?
We are not your dreamt role models, I'm afraid. I should have liked to be a pianist. Yeah, but I wasn't very good at playing the piano.
Okay.
So.
Yeah, that's maybe quite, yeah. And how did you roll into? Did you take everything apart at home, or how did you become?
Yes, I grew up in a taking things apart household. My father, my brother were of the taking things apart variety. Yeah, I grew. Science came natural to me.
Okay.
It was never a question in a way.
We're going to talk about a very important issue, and that is, and I think it's an issue that's growing and growing in a way of importance. To survive with, in 2000, I'm referring it sometimes, in 2056, there's going to be 10 billion people on Earth, and at that time society must have switched to fully sustainability economy within a century. Well, at least that's what Nick is actually saying. And the growth has to become, from a large part, from unproven, immature, can I say it like that, technologies. And we have to abolish almost, well, 99% of the energy infrastructure we have today. And I wanted to discuss with you what the challenges are, but maybe I want to invite you first to say something about where are we, why are you in the field of your expertise, and maybe you can start, René, with telling us something about that.
I'll be happy to do that. I'll take a bit
Walk around, take the stage, it's all yours.
Because I would like to talk about the sun. This is the sun, and to give a few words for Nick, this is the world's best and the most efficient fusion reaction, fusion reactor. We don't need another one, in my view. This is there, perfect, it works, 100%. It's cheap, it's for nothing. The only point is that it's a bit far away, but it brings us a lot of energy. As human beings on our planet, we use 2,400 watts of power continuously. 2,400 watts continuously. That is an enormous amount of power. You and I, being, at least me, untrained, I can maybe deliver on a bicycle something like 100 watts. So that's only a small percentage of what I really use, is 2,400 watts. Yet the sun gives us so much energy that 2 to 3 square meters is enough to give me all the energy from the sun to make this 2,400 watts possible. The sun delivers, on its nice sunny day as today, on our ground, 1,000 watts per square meter. It's more than enough to live from. The only thing that we have to do is work on it. And of course, if the sun wouldn't be there, photosynthesis would not be there. And if without photosynthesis, we would also not be there. I just said the sun is the best fusion reaction on the planet. If you talk about chemistry, this is the most beautiful chemical reaction that you can think of. It is a very unlikely reaction. So if you look at the chemistry, if you are in first-class chemistry, you will see that it is impossible that 12 molecules at the same time come together and make a sugar molecule. They don't do this. It's an enormous cascade of steps that happens, and it all starts with absorbing one photon or a few photons from light, and from that you get an electron transfer, you make charges, and from these charges you can oxidize water and reduce hydrogen. And actually this hydrogen, nature is a kind of funny system. If we think about technology, then photosynthesis is nothing else than just making hydrogen and store it in the carbon dioxide. Nature didn't have a big vessel to put it full of hydrogen. So what it did, it used carbon dioxide to hook up the hydrogen and take it off when we eat it and burn it again. While being very nice and very good, and good for us to eat and to breathe, because we can also get oxygen from this, it's the most important and the most beautiful reaction on our planet. It's not very energetic efficient. It goes with a really pathetic efficiency of only 0.5% or even less. So we cannot sustain our world by just doing photosynthesis. And all the energy that we are using now, much of the energy that we're using now in terms of fossil fuels, is basically photosynthesis from a million years ago. So you can do just photosynthesis and wait for 60 to 200 million years, and then everything will be fine. The only problem is that we are now raising our carbon dioxide levels, as everyone knows. So we're trying to do something new. And when our sustainable future is the sustainable future that is the future on the sun, where our planet is driven by solar light. And those people that say we also have wind, I say wind is also solar energy. There would be no wind if there would be no sunshine. So wind is a kind of very nice renewable energy, but it's secondary to solar energy. Sun energy drives the wind. And we can take off panels, we can take futuristic cars that win prizes, and maybe in the future, maybe far away, maybe not, we can fly on a plane. If you look at this graph, it's an incredible graph, but you can see all kind of lines, and there's all kind of technologies that are being developed for new solar cells. And this is where we are working. We are working in the lower half of this graph, trying to push new types of solar cells to higher efficiencies. And we do that by doing all kind of new materials, trying to understand, develop materials that absorb sunlight and that make sunlight convert into charges. And we try to use technology to do that. So every day we try to improve and understand how solar light can be used to generate charges, to generate electricity. And with that electricity, we can make it into technology, maybe. It is our work on organic solar cells, which starts as a very small scale, few centimeters device, but slowly is emerging into a larger panels, larger technologies that one day might be on your roof or in your building. And early examples of that are already appearing. This is images that is made with panels made by some startup companies in this field, company in the US, and this is from a company in Germany, where they are already making organic panels on buildings, in glass, in concrete, semi-transparent, that are fully integrated in the building and that allow also, from an architectural point of view, to make a nice building. So solar cells will be very important for our future and will change our world. But there's one other thing that we need to do. If we really are going to rely on solar energy in a large scale, then we all know that only at maximum, at least in the middle of the year, we have 12 hours of sunlight and there's 12 hours of darkness. And this darkness is especially the time when we want to switch on the light. So what we have to do is to store some of this energy. And also for transport, I showed a plane that might take off on solar light, but it's unlikely that it will be full of batteries. So we need to store energy. One way to store energy is to do exactly as photosynthesis does, but do it a little bit better. Use the charges that we make to do some catalytic reaction. To split water into oxygen and hydrogen, to reduce carbon dioxide, maybe into methanol or methane, and make fuels out of that. And this is an example of work that we are doing to make a kind of what we call artificial leaf, something that makes chemistry with light, something that makes a real product. And here water is plated water is making hydrogen and oxygen. And in the future, you could think of panels that make hydrogen, that take carbon dioxide, make it into fuels, and make it kind of using the carbon dioxide from the air, using hydrogen that we make photochemically, and convert it into fuels that we can use again. And of course, we have to still build this. And this is easy on a small scale, but it's very difficult on a large scale. Energy is a large-scale problem. On a small scale, it's easy to solve. On a big scale, it's a real challenge. And that is a challenge that we have to face. And luckily, some politicians also get this idea. This was a quote from the State of the Union from Obama last year. It was January 2015, where he says, if Americans want to win the race for the kinds of discoveries that unleash new jobs, converting sunlight into fuel. I think the first part of the sentences may be important, but it's not our goal so much to make new jobs in the US. But I think for a sustainable future, it's important to do this. And with that, I'd like to thank you for your attention.
Thank you so much, René, and great that the President is backing you up in this, although we do have a lot of challenges. I want to talk about the challenges, but before that, I asked Nick actually to say something, and actually I want to start. There is this joke of fusion. You were teasing him at the start with your son joke, but there is this joke that they say fusion is still 50 years away, as it's always been. Yes, I thought that's a great start for you. Where are we, Nick?
Yes, thank you for that.
You're welcome.
I know that joke, actually, and it must be because it's been around for some time. Actually, do you know the history of that joke? Maybe you don't, but it's been around for 180 years. Yes. And about 120 years of those 180 years, it wasn't about fusion, it was about solar panels, actually. Because the first solar cell was made, actually working solar cell was made in 1839 by Becquerel. And then it took a bit of research to get it to the point that the first working solar cell was made 120 years later. And from there, so this was already close to commercial, it took another 60 years now to get to where we are, which is where we are making solar panels at a massive scale, but still producing only preciously little of our electricity. I'm not saying this to be rude to René, but to press the point that from fundamental discovery through research, through painstaking development, to something that actually produces energy on a world scale takes a long time. So maybe as a fusion scientist, I'm the expert in things that take a long time, yes. Fusion. Let me say a few words about fusion, then we go back to the long time scales, which in a sense is more important. Okay, hack a hole in the roof, look out, and you see on this beautiful sunny day, the sun. And most of you have probably once in your life thought, that sun is producing a lot of energy already for a long time, and we hope it will do so for a long time to come. Now, 100 years ago, it was a complete riddle why this could be so. So this is relatively new science. But then it was discovered that the sun runs on fusion processes. It combines hydrogen atoms and makes bigger atoms out of those. So when you said that without the sun, we wouldn't have photosynthesis and life on Earth, we wouldn't even have atoms that are bigger than hydrogen. We would have been clouds of hydrogen, if you want. But yes, so that's the process that runs the sun. In fact, it's the only energy source in the universe, and it's incredibly powerful. Let me just do a question. Why don't I ask the chairman of this university? I have a glass of water here. It contains a little bit of heavy water, deuterium. Suppose I could fuse that with equal amounts of deuterium or tritium, even heavier water. How long could you run your household on that?
Green card for 1 week, red card for 1 month.
Yes, let's do a democratic assessment.
Green card for 1 week.
A week.
Red card for 1 month.
I think our president has a right of a first vote. Oh, well, there's a lot of red cards. A week. That was a week, you said? Okay. Anyone more than a week?
The green one is 1 week, and the red card is
yes.
1 month.
Okay, a month. Well, it depends a little bit on your house, in fact. Yeah. Well,
you're a scientist.
Actually, that is spot on. Between a week and a month is just right. But there's a lot of water in the oceans, and this means we could run the world for about 50 billion years. Yeah, 50 billion years. Is there anyone who is complaining about that? It means we have 45 billion years to think about that question in the dark. Yeah. No, but so if we get this process that runs in the sun and other stars on Earth, it would be wonderful. We have energy for everyone, for forever. It's clean, it's absolutely safe. Yeah, there's only one problem. It doesn't work. It's not possible to make it work on Earth because it requires temperatures of hundreds of millions of degrees, and it produces a lot of energy in a very small room. So you need materials, and you need very strong magnets and things like that. If you say it's not possible, of course, engineers like the students at this university think, okay, sounds good. Let's try and do it. And this is what's been happening for the past 50 years or so. So if you want a figure of merit, it has increased faster than Moore's law. Its improvement has been better than that of computers, but we are not there yet at all. We are building a fusion reactor that's very big, and that will produce about as much electricity as it costs to run it. And from there we have to scale up. So halfway, I would say. Having said that, I mean, if you want to know more about the science and technology of fusion, just ask me in the break. But I wanted to go back to those long time scales. Suppose you had a new energy technology, and you had developed it in the lab, like the things that René just showed you. And suppose you had grown it to a point that it produced 10 megawatts of electricity. That's a lot of power, right? How far are you at that point? You probably know or may not know, but the world needs about 20 terawatts of power at the moment. So if you want to come to be visible on the radar, you need something that produces, well, at least 1%, I would say, but let's take 0.5%, so that would be 100 gigawatt. That is 10 to the 4th more than your 10 megawatts. And 10 megawatts is already a very big thing. I mean, it's way out of the laboratory. 10 to the 4th, in this digital time frame, you'll probably know that is 2 to the power 13. So it's 13 doublings. There's no process that goes faster, development process that goes faster than doubling every 3 years or so. So that would take 40 years. So maybe there's another joke in there, I don't know yet. That would take 40 years. So are you there then? You would say, okay, a few doublings more and you're there. But it doesn't work like that, and I'll explain you why. So here's a graph. It says the number of units installed or whatever energy power unit you want. Here's time, so this is years. We'll fill that in later. And suppose you need to go to some final level, say all the energy the world ever needs or so. The fastest way to get there is by a straight line. Yeah. Because if at any point, if it wasn't straight, if at any point you could have gone faster, you should have gone faster, so it should have been a straight line. Now we have to think about the slope of that line. That is going to determine how fast you can go. And in the end phase, you have installations, and those installations last about 50 years in energy technology. So you have to replace only 2% per year. So your final industry has to be able to make those 2% per year and not more. Your industry is not going to ever produce more than that. Because if you made more industry, you would have to dismantle it afterwards. So that determines your slope. So if it lives 50 years, this straight line also takes 50 years. Now, at the beginning, of course, you don't have the industry at all, so you first have to build that. And that is the exponential growth that I just talked about, the doubling every 2 or 3 years. That also takes 40 years. And there's a mathematical equation that you can work out very easily. So if there's a time scale involved or associated with the exponential growth, and there's the linear time scale, which is basically the replacement time, then the turnover from exponential growth here. Oh, sorry. The turnover from exponential growth to linear growth is at the ratio of the two time scales. And because one is long and the other is short, this is at about 10% or so of the total. So you have to add the two time scales. There's no fast way to make the energy transition. And this is why we have those jokes. They're not jokes, really. They're very serious business. So this is twice the same graph. Once as a linear plot. This is what really counts. This is the number of items installed. But if you plot it logarithmic, you'd say, here, this is going good. This is going fine. This is what you see in the newspapers, because that is where you say every year we get so many more solar panels or windmills, for instance. But the same graph here shows you that in terms of actual production, is almost meaningless. It's just the investment to make the industry that will allow you to go up here. Good. Exponential growth is spectacular, but it really is about the linear phase, which comes after. All right. I hope I'm not discouraging you, but when you see that wind and solar is growing very fast, it's because they're still in the exponential growth. We still have the linear growth to come. So this is why any form of energy transition will take basically the remainder of the century. It's a process that you can hardly force. Well, this is historic data, and I really was working with Gert-Jan Kramer on a paper about this. This is historic data, and Guido Lange, not to forget, who worked out most of the data. This is for fission, so this is the model that I just described. This is wind, this is solar, and you see they're in the exponential phase, and they should roll over at some point. And it's only here where they're really producing energy. Fusion, as said, is about 50 years later, and we're not even sure we are going to do that. Well, long time scales, I should round off. You're maybe not aware of the fact that the streams, the floods of refugees that we get in Europe, that are leaving Syria in particular, that this process was set off by a series of years, 5 years or so, of droughts in Syria, years without precipitation. This was a wealthy country, and all the cattle died, and all the farmers, wealthy farmers, went to the cities, impoverished, and destabilized the entire social system in the country, and this is what led to the political instability, and now what we see here. Was this caused by climate change? There are actually papers that say that the probability that such things happen is much larger now, but we can't prove for sure. But definitely this sort of massive worldwide upheaval could be the result of climate change. And this is a risk we cannot take. And we don't need to take it, because it's a problem that can be solved. It can be solved. It can be fixed by research and development. But we have to do it. This is not a funny problem. It's not giving nicer things to the world. It's just making sure that the world doesn't kill itself. So the gravity of this problem, although the research may be fun, but this is a really serious problem. We have to solve it. I think I stop here for a minute.
Yeah, thank you for this cheering word. No, thank you for the cheering words. I asked you to address this because it's very important. Another thing is that you're kind of teasing each other a little bit, but it's not a real battle between you. It's not my Jerry Springer influence on you. But in a way, do you often feel you have to defend yourself because of what you're now saying? That, so when is this fusion going to start? Or because now we're touching the fundament of actually fundamental research and the importance of it, no?
Yeah, the most critical questions about fusion I get from myself.
Okay,
I would agree to that. So I think that the research in science and research on energy is important anyway, whatever is the outcome of it, because we cannot afford to miss a solution. Yeah. And for many of the energies, whether it's fusion or solar cells or wind or anything else, we have to that is what we as scientists also have to do. We have to find out what is the truth behind it, what is the real thing behind it. And only after we have researched it, we can tell you whether it's going to be part of the exponential growth and the linear growth and the contribution. If we don't figure that out, we will never know.
That's true, but there's a difference in drive, in a way, for a scientist. I think when we were talking about this, you're addressing that it was a difference in years, the drive of scientists. Usually you wanted to be a scientist, and then came a time, maybe you did it for the money. And now we can see, actually now on the technical university, it's more the ideological way of coming with solutions. Do you see that way? The change in the drive of a scientist?
I think we see it in our students, definitely, that we get a lot of students who come to the university. You see it in the My Dream Is posters. There are a lot of like societal engagement dreams, and I'm very happy with that. Yeah.
I'm too, but also happy with the fact that there is also a lot of students that just want to know. that just are eager to know something.
Yes.
There's an essential difference between the two.
Not an essential difference, but
it's
sometimes it can be in the same person. But trying to figure out.
But it's funny because you're more in applied scientist and you're saying this.
No, but the most joy we get from on a daily basis is not. We're making small steps, so we cannot say at the end of the day we brought the energy solution closer. What we can say at the end of the day that we understood something maybe that we didn't understand at the beginning of the day.
But there is a major difference between the two of you in your expertise, is that you're making small steps, like a lot of small steps, and you making hopefully a big step, but then all of a sudden like one big step. Right? That's the big difference.
Yeah, no, definitely, yes.
I hope.
He makes small steps, I make big steps. Yeah.
But as I said, of course, making a lot of small steps also helps you to climb a mountain. And people are thinking that solar energy might still be far away, but it's really it will be there in 10, 15 years from now. Already a few years ago, when we had this warm summer, half of the electricity generation on midday was in Germany generated from solar energy. Half of the electricity for a total country like Germany. Yeah. It's not far away, and the graph of Nikke is very true, of course, but it's not far away that we'll get to levels that solar energy is really going to be an important part of our energy production, and it will so in the next part of the century, for sure.
A good thing is in the better science that whether you're right or wrong, you can actually see that. You can, science. With science you can prove it. The only thing is, I think maybe the biggest problem is people are maybe not so good in anticipating, because the main thing is that we actually realize the challenge that we have to work on energy now, as you would say, still invest in it. I think there's more money spent on the banks in 2008.
The bailout.
Yeah.
The bailout cost, what was it, 4 times more than all the budget that was ever spent on space research, which is again a very large, much larger amount of money than spent on the rest of research. Yeah. So yes.
And the rest, what are the big challenges you're facing?
That's a good question. No, I think for the work that we are doing is we want to develop these novel technologies for solar and see whether they can contribute to the energy supply for our society. That is, I think, the important goal of the work.
Yeah. Agree on that, Nick?
Well, can I just say that you said about who's right and wrong. It's not right and wrong between solar and fusion, of course. If solar can save the world, I'm equally happy. I'm even more happy than if fusion has to save the world, because fusion is very difficult, and if you can, if you can do without, it's better for the world. Yeah. And the science will have been fun anyway.
It's funny you say that. You say if we can do without, it's better for the world.
It's
it's a humble way of saying that when it's your field of expertise.
If we can find a simple way of solving, a relatively simple way of solving the energy crisis, let's do it. Yes, by all means.
Okay. Yeah. As I said, in 2056, there's going to be 10 billion people on Earth. The TUe, we're going to be sitting here this afternoon as well. Well, I don't know if we're going to be sitting here, but anyways, it's the 100 years of the Technical University. Niek, when you would look out of an arbitrary window, what do you see in 2056?
Yeah. There are three scenarios. Three scenarios. One is the bad scenario, which has a rather high probability. You'll be seeing a world that is maybe you'll see water actually where we live, and so we don't solve the energy. We do not do the energy transition, and we get old-fashioned energy. We get climate change. We get through any window. You'll probably see a lot of people you didn't know yet. In the better scenario, you'd see a lot of solar panels and windmills and things like that. You will see energy production everywhere in all sorts of forms, and just the area that we have at our disposal in the Netherlands is just barely enough, in fact not enough, to make the energy that we need. So you'll see it everywhere.
In the landscape?
Yes. Yeah. It will be governed by energy production. Yeah. And in our dream scenario, we'll have become much smarter, and we have realized that we can do things much nicer, and we have better solar panels and maybe very small, nice, cuttable fusion plants and things like that. And the world. So we'd be looking at green pastures and small animals that walk around.
Do you also have three scenarios for this question, René?
No, I have no three scenarios. My scenario would be that I hope that in 40 years from now there is still something to dream and something to dare.
For you, the nightmare would be if there's no challenges anymore.
My nightmare would be. So yesterday we had a very nice celebration of our university in the town, and 4 young people spoke about their dreams and their dares. And part of them were personal dreams, but I think it is very important that in 40 years from now, there are still young people that have dreams and dares, and I'm sure that there will be floating some water somewhere, and there will be green birds, and there will be problems. I also wish them problems to solve. We are trying to solve a few problems, but no doubt that in 40 years from now, we have solved together solar with fusion, all the energy problems. But there will be other problems, and I hope that they will be not too severe, but challenging and nice to solve again.
I trust on that. Thank you so much. Nick Lopez Cardoso and René Jansen. Thank you.
A very warm welcome from me and Corinne. It is a pleasure to be here. I will talk about things related to data. So as you know, there is the Nationale Wetenschapsagenda, the Dutch National Science Agenda. And there citizens are asked to tell what they think is important that research should look at. And if you look at the science agenda, you will actually see that many of the questions were about big data and data science. On the one hand, people see that many things will become much better, much more efficient, much smarter, from cars to energy to government and all kinds of things. But at the same time, there are also very big concerns. So there are not just technical problems, there are also societal, governmental, economic, and ethical sides to that. And that's why I'm very happy that I could invite Corinne today to talk about our dream, and our dream is responsible data science. How can we use data in such a way that we do not have the polluting side effects of using data? So that's what we would like to talk about today. So the theme is responsible data science. So we would like to make data science responsible. And I think everybody in the room has heard about the big data, has an idea of what the idea of data science is. So our society is generating enormous amounts of data. These can be cars, these can be energy systems, these can be social media like Twitter, Facebook, There are all kinds of sources of data. They produce huge amounts, and the goal of data science is to turn this data into value. As we have all this data and we want to do something useful with it, and that requires multiple disciplines cooperating together. So it's not just analytics, there are also things related to, for example, ethics, visualization, and other types of things. So what we produce with this data are answers, decisions, and insights. These are the things that we would like to have. So if I make it a bit personal and I look at the things that I'm doing myself, I'm interested in analyzing dynamic behavior. And we are analyzing dynamic behavior by just looking at the events that we can get from all kinds of data sources. So what you see here in this, on this slide is just data, as we could extract it from an order handling system like SAP or something similar. But it could be a hospital database, it could be social media, it could be anything. So we take this data, for example, here we are analyzing 12,000 cases generating 160,000 events. For us, this is a very small data set. And we can automatically produce process models, behavioral models, that tell you what is actually going on. So this is a bit like magic. It's extremely powerful. So when we do this, we can see in any type of process, where are the bottlenecks? And if we identify the bottlenecks, we can think, who is causing them? And then you see that you get economic, social, business, ethical, all of these things start to play a role. We can also analyze the cases that are being processed here, and we can learn information about customers. So what are the demographics of customers that typically pay late? So just by a push of a button, we get models that explain us these types of things. So this was discovery. We can also do conformance checking. What you can see here, of the 11,000 people that were supposed to make a payment, for 31 cases we were missing a payment. It was skipped. And again, we can analyze what are the types of customers that do not pay with the push of a button. What we can also do, if we look in the process and we see deviations, for example, in a hospital, we see that certain doctors deviate and others do not. We can try to analyze what are now the effects of these deviations. Are they harmful or not? So this is incredibly powerful. We can make things more efficient, faster, smarter, more compliant, all kinds of good things. But at the same time, because we can do these types of things with a push on a button and analyze terabytes of data, it also comes with a very great responsibility, because you can learn all types of things and you can misuse this data in all kinds of ways. So we would like to talk about 4 areas that we are concerned with, where there are scientific challenges that need to be addressed. So Corinne will talk about the 2 things at the bottom: confidentiality, so privacy-related issues that everybody can imagine that these are important, but also transparency. When we generate results, for example, you reject an application for a scholarship, it has to be transparent why you are rejecting it. Or you get courts operate based on algorithms. You want to understand the algorithms that make decisions whether they sentence somebody to jail or not. I will talk about the top parts, fairness and accuracy, and I will explain these in a minute. And what is very important, because this discussion often becomes like that people say, well, we should not use the data. That can, of course, not be the goal. We want to have a positive solution. There are technological challenges that we have to solve to make the use of this data very well. So the first question is about fairness. So how can we make sure that if we use these types of techniques that we are not discriminating certain groups of people? This is one of the questions that we would like to address. So if we go to this university, there are students that are applying for a scholarship, and we have to decide which are the students that get the scholarship and which are the students that do not get the scholarship. So you have a decision process. Certain people get a scholarship, other people do not get a scholarship. So now we would like to build algorithms that help us to make this type of decision. So what you then need is you need training data. Yeah, so you look at students in the past. For example, here we look at a student called Peter, 28 years old, male, German, has certain hobbies and has a certain favorite food. And if we look at this historic data, we see that Peter took 8 years. And now suppose that all of the people that have this age, that are male and come from Germany, that just by certain properties, they typically take a longer time to study. And we put that into algorithms, then we are going to reject all older German male students. And it would be very unfair. Everybody in this room would say it was very unfair if you have these demographics that you always get rejected. So what do people say? You should not do this. You should remove these sensitive attributes. So it could be exactly the same if we would talk about females or the color of the skin or the income of the parents. There are often certain attributes that we would not like to use. So what we could do here is we could remove the attributes age, gender, and the country where people come from. So we remove that from our problem, but then we still implicitly have the sauerkraut and the Fußball. So our algorithm will give exactly the same result. So even if we would remove these attributes. And that explains a bit the challenges that we have. So one of the things that we can do is that we can force the algorithm to be fair. So there are all kinds of ways that you can say, we need to optimize, look for the best students, but the constraint is that a female student and a male student have exactly the same probability. Or that a person from one country has the same probability as a third person of another country. So we can put that into these algorithms, and then it is guaranteed to be fair. The paradox is that for these algorithms, to ensure that they are fair, you have to use these sensitive attributes. So I would like now you to vote on the following question. So take your cards. Is it allowed to use sensitive attributes, like for example gender, age, color of the skin, to ensure fairness? Because what I just tried to explain you, to ensure fairness, you need to know what you want to be fair about. So who is in favor of allowing this and who is not? Please. So I think it's 2/3 green, 1/3 red. There is no right answer here, by the way. Now I would like to hand over to Corinne, who will look at the following dilemma.
Just noted that the majority of the University Council voted against. So, in case you... Yes, I know I said the majority. Okay, confidentiality, our second challenge. Confidentiality is usually related to privacy, but there is a difference between the two. Privacy relates to much more than just confidentiality. It relates also to quality of data. It relates to access to data, and there is the challenge for confidentiality, because confidentiality is not about keeping things secret. If we were to keep all data secret, we couldn't use data, we couldn't interact with each other. So the real challenge is in sharing data, in dare to share. So the real challenge with confidentiality is thinking about a context and thinking about balancing and a balancing act between, on the one hand, the interest of keeping data secret, and on the other hand, the opportunity, the necessity to share data. Under what conditions do we share? Under what circumstances do we keep data confidential? And thus far, we have arranged this balancing act by means of contracts or agreements. Suppose you go to the doctor. We all have the feeling that certain data, our medical data, are being kept secret there. They're not shared with the bulk of you. They keep being kept secret in the relationship between you and your doctor. So confidentiality very much relates to a context and that context can be arranged, and the conditions for confidentiality can be arranged by means of contracts, can be arranged by means of technological facilities, encryption, for example. Thus far, it's a rather easy world, but so just to wrap it up here, that's what I just referred to, but there's Obama again. This time, referring to something that big data brings to us. So you think of it why he says he's not your dad. And that's because big data brings us something extra. Big data brings us add-on information. It's the distinction between what is often referred to in literature, my digital footprint and my digital shadow. What I leave behind, what data I leave behind on Facebook, Twitter, on the internet, purposely, that's my digital footprint. What Facebook makes out of it is my digital shadow. They add on information by smart applications, by data mining, and they profile me in accordance with a certain type of Korean prints, whether or not I eat sauerkraut or something else. So Obama knows something more than just the digital footprint of that small girl, that little girl. The add-on information is crucial. The add-on information is what data science, what big data brings us. We know more than just 1 and 1 is 2. It's 1 and 1 is 3. Then returning to confidentiality. That means that when I share data with the members of the university board or any of you, and I think, or I expect, or I trust that the data shared between us are kept confidential, yes, that's my digital footprint, that's being kept confidential. But in the meantime, a colleague of mine here, other organizations, can add on information. And what's the interaction and the relation between confidentiality and that type of information, the new information? Is it still possible for me to know what information is being generated, is being shared? Hence, with big data comes a new responsibility, a new challenge in thinking about mechanisms and new ways, whether technological or based on contracts or any other facilities law, in that we have new means in thinking about how to relate to confidentiality of these digital shadow type of data, how to relate between sharing and keeping secret of data that we don't know that can be generated in 1 year time. Hence, confidentiality is a challenge right now. And just think of whether you have a feeling that the data you put on the internet right now, or that you share by means of any facility or platform on your mobile, whether they are truly kept confidential. And add to that the challenge of data science, and my question would be, confidentiality, can that go hand in hand with data science? In other words, if Will and I, and many others, striving for responsible data science, striving for new mechanisms for confidentiality, is there truly a way forward in realizing confidentiality when it comes to data science, when it comes to these new opportunities of using data, adding on new information? Just a simple question, do you see a future for confidentiality in a data science-based world? Yes or no? Well, Will indicated we should be positive, so yes, I think the green has the majority. Will.
Thank you. So, of course, one of the elements which is very important is that the people that use these powerful tools, that they have the right type of education and the right types of tools. So if you have results, they should be accurate, so that people can trust them. So if people apply data science without a proper education, it is very easy to make mistakes. And I will illustrate some of these mistakes. So you can look at correlations. You just analyze the data. And then you will see that there is a very strong correlation between the sales of iPhones and people falling dead from the stairs. There are also an incredible number of relations related to the sales of butter and all kinds of other things. There's also a relationship between the number of computer science doctorates and the sales of arcades. There are these strange correlations. So the principle behind this is that if you have lots of variables and you have lots of hypotheses, if you search long enough, you will find something that holds. So if you look for many different patterns, in the end you will see patterns, but the question is whether they are really, they say something meaningful. In order to illustrate this a bit further and the dangers of this, and that's now a topic that is every day in the news, how can we find terrorists? And I'm now going to make a very simple mathematical exercise where we are going to look for terrorists. So I have this belief, and let's suppose that the Dutch government has the same belief, that if people stay 2 times in the same hotel, that is very suspicious. Yeah? So we have 18 million people in this country, specifically in this hotel, by the way. We have 18 million people. Suppose that everyone stays once in every 100 days in a hotel, random. That hotels have a capacity, or they have on average 100 people, so that from that you can derive that you have 1,800 hotels in the Netherlands. Yeah? Simple mathematics. So we find suspicious if 2 terrorists that do not wear these types of clothes, if we can spot that they are in one hotel, a person A and a person B, and a bit later, these 2 persons are again perhaps in another hotel, perhaps in the same hotel, that is very suspicious. So if we would look for a 1,000-day period of these Dutch hotel visits, could we find terrorists? So let's do a bit of reasoning. So it's a very simple calculation. So what is the probability that 2 specific persons, P1 and P2, stay in the same hotel on the same day? So that's the probability that 1 person stays in a hotel, the probability that the second person stays in a hotel, times the probability that they stay in the same hotel. So we get this small number. So it gets even smaller if that event happens twice. Then we have this to the power 2, we get this very small probability. So Mr. Falvey says very suspicious. This is very, this is a very small probability that this is going to happen. Let's put all the people that have this type of behavior to jail. But let's do a bit of more reasoning. So like as a small intermezzo, on Monday, John Glees will actually come to this university and will open, let's say, the corridor of silly walks. So let's do a bit of further reasoning. So we have this incredible small probability that people will stay in the same hotel on 2 different dates. But let's look at how many combinations of people and combinations of dates there are. So first we have the number of combinations of dates times the number of combinations of people, so we have this number. Now we need to multiply these 2 and we find how many suspicious events we find in the Netherlands. So we find 250,000 suspicious events of 2 persons staying in the same hotel. So we would need to put hundreds of thousands of people to jail. So this is illustrating that good tools and good education is incredibly important so that you don't derive the wrong conclusions from the data. People say often, let the data speak, but if you use it in an irresponsible way, you get bogus conclusions from that. So I would like to go to the question. Let's now, for example, that we have a court and we have a very good algorithm that can make decisions, and it is accurate in 99.9% of the cases. Should we use this algorithm or not? So please show what you think. So I can see that I can really influence you because I see lots of red things here. So, Corinne?
Very happy with so many red cards. Final challenge, transparency. I came by train from Tilburg to Eindhoven, entered the campus, and there was this icon at the beginning of the campus saying CCTV cameras here. That's an icon to be transparent as a university in making known that there are cameras everywhere, recording your behavior here at campus. That's merely a sign for transparency. But the key question then is, how transparent is this university by means of its icon? In other words, what's transparency in a world where we do not see what is actually being done with data? How many cameras? How smart are the cameras? What data is collected? What type of smart analysis algorithm is applied to finding out how many terrorists are at this campus or visiting this campus in a certain period? Transparency is crucial for many reasons, but it's a challenge as well. Transparency and data science means thinking about a transparent society, a society in which we know almost everything about everybody. How transparent do we want our society to be? Aside from the quality of the data on which we argued. But transparency, as said, is much more. Transparency is being open, the icon. And open also in that I subsequently, having visited this campus, can apply to, I don't know what office at Eindhoven University, but apply in asking, what data do you have on me? What type of behavior on campus did you record? What do you do with the data? How long do you keep the data? What quality guarantees do you have on the data? Do you share data with others? Transparency on use of data, becoming much more complicated in a society that is using smart applications such as data science applications. But there's a subsequent challenge as well. Not only being open, but also explain, being held accountable for the decisions that we as a society make on the basis of data. We'll just show the example in finding terrorists in hotels. That's an interest of fighting terrorism. That's an interest on the one hand, privacy invasion on the other hand. If I were to ask you, are you against the fight, or I should frame it differently, are you against the fight against terrorism? You would all say, no, of course not. We want our security to be safe, our society to be safe and secure. You're not against safety or against security. But if I were to ask you, are you against privacy? The same answer would be no, of course I'm not against privacy. The key challenge here is balancing act between, on the one hand, safety and privacy, efficiency and privacy. And it's that balancing act that is crucial, but with data science, our challenge is, of course, how to implement the balancing act in technology. How to implement normative decisions on how we see and how we relate to society in technology. Is that possible? We'll start it off with the challenge of being fair and fair decisions, and he decided to leave sauerkraut in. But you could, of course, argue sauerkraut to be out, the analysis. We decide as human beings on how we relate to our society, what type of society we would like to have now and in the future. That means thinking about fairness, thinking about accuracy, thinking about confidentiality, and thinking about transparency, and balancing benefits against risks. So using, it's IT here, but I couldn't find a picture on data science. Using data science is the hardest part. Collecting data as such is not difficult. It's sharing, reusing. That's the hardest part, because it requires us to think about balancing. So challenges are, for example, with data science, there's something like we could call a black box. And in that black box, we apply algorithms. And algorithms are making smart decisions. Can we as human beings, as a society, still be accountable for what algorithms do? Can we open the black box in the future? And who is making the black box? Can we present and communicate to laymen what's happening within the black box? So transparency means being accountable as a society. How can technology be made accountable? So, a key question would then be, do we leave that up to partners in society, to organizations that apply data science, to the government, the police, that applies algorithms in finding terrorists? Or do we want some sort of guarantee, for example, incorporated in legislation, that offers us as a society a stick or a requirement to put on the desk of organizations such as the police that requires them to be transparent, to create algorithms that are accountable, that can be made accountable. In brief, is it necessary to introduce legal rules to open the black box of data science? Or do we have faith in data science as such, and we do not need legal rules that offer some sort of backbone and context? Yes or no? Wow. Okay, I'm happy to be in Eindhoven. Okay. Wrapping up, that brings us to one of the challenges that Eindhoven University and Tilburg University enter these upcoming years, and that is Marienburg, where we try to combine these 4 challenges with many other challenges in relation to data science, where we train and educate our new data scientists of the future in not only applying data science, but applying responsible data science, being responsible in applying data science. Will, what are we going to do there?
We are going to do beautiful things. And what this discussion and also the answer to the questions illustrate is that we need to do it together, and we need to have multiple disciplines to answer these very difficult questions. What will happen in this building is that as of September there will be a new master in data science, next to the masters that we already have, both at this university and at Tilburg University. What will also start on the 1st of September is a new bachelor in data science, which is a shared effort between the University of Tilburg and our university. And we expect that there will be many, many people that would like to take this type of education. There's lots of enthusiasm by young people. I think I was one of perhaps the first professor in computer science that actually studied computer science. So I know how computer science emerged from mathematics. And I think we see next to computer science and mathematics and all the other disciplines, we see really a new discipline emerging, data science, which requires the type of collaboration that we presented today. Thank you very much.
And then Also, for the two of you, my final question: if it's 2056 and you look into the classroom, what do you see?
Well, I saw the numbers that Frank projected, like in recent weeks, based on how much money we get for the students. I think that there will be no classrooms, actually. There's no money left for it. But I think the positive news is that I think in the future there will be very much a blending between the virtual world and the real world. So I've been making a very successful MOOC, let's say a bit more than a year ago, and that opened my eyes that education as we know it today will change dramatically.
Yeah. MOOC is like university on internet and learning from internet. Yeah.
I think what's very important for university is that it is a social place where people enjoy coming to collaborate, and the coaching aspect is very important. Pushing information in front of a classroom, I think, will become less and less important. And that's why we don't need classrooms in the future.
Thank you for that answer. And now, you were referring to 40 Towers, Monty Python, for something completely different. Corinne, in 2056, will the city of Eindhoven still be the hometown of the Technical University?
Wow, you're asking someone from Tilburg to elaborate on this.
That's why you have this objective view.
Yeah, of course, I think Eindhoven will move to Tilburg. No, that's the easy answer. But Eindhoven definitely moves somewhere in between. Den Bosch, we just saw. I think in Dare and Dream, I dare to think that universities in this time, but in particular in 15 years, when we celebrate our 100th university, that a university is much more than a campus-based university, whether it's in Eindhoven, Tilburg, Den Bosch, anywhere else from the world. We'll already refer to a virtual classroom. So I would think that it is not a good thing if Eindhoven in that way stays. Eindhoven University in that way stays in Eindhoven. It has to use these huge opportunities of a world without borders. But I dream, we'll just refer to, there still needs to be something like a classroom, a traditional classroom, where you have a face-to-face contact with your professor. So my dream is definitely that Eindhoven will celebrate its 100th anniversary right here in Eindhoven. Yeah? So let's work on that.
Thank you so much, Corinne Prins and Wil van der Aalst. Thank you so much.
Thank you.
Welcome. First of all, before we start, can I ask you a question?
Sure.
Because we were discussing the dreams and the dares, being a pilot, either on the ground in the air. What was your dream when you were a young boy?
Well, actually, I came from a family of engineers, and automatically I became an engineer because everybody in my family is an engineer. But I wanted to study philosophy, and I did that later on. And now that philosophy of technology is my field, I think I lived my dream.
So now we're going to be contemplating, but first of all, we're here celebrating the 60th anniversary, and that's exactly, you want to be as a philosopher, you're going to be reflecting on that.
Okay, I'll try. Well, so this week we celebrate the 60th anniversary of our university, and its founding fathers, people like Dorgelo was the first rector, we had Postumus, who was the second rector, and we had also Holst, who was by then the director of Philips Research Laboratories. They all had a mission. They were thinking of a university with a mission, a societal mission. And the mission was to educate a generation of new engineers who could contribute to rebuilding the south of the Netherlands. That was one thing. And the other thing was try training engineers who would use technology for the good after all the destruction that what happened because of all kinds of technological means in the Second World War, and not just by nuclear technology. So, University of a Mission, and I will come back to that later on. Now, 60 years later, 2016, we are witnessing a number of technologies that will, in the next 25 to 40 years, change our life dramatically. And there are several of them, and I will just mention 4. So genomics, that's the area in which the genome, also the human genome, can be edited. Increasingly, it could be faster, cheaper, and there are many, many more possibilities to do that. And it could be used in 2 ways, either to cure diseases, but also to improve the human being. And that is something to think about. A publication in Nature Genetics last week tried to relate the notion of happiness to some sort of genetic makeup. So in a population of 300,000 subjects, they investigated the human genome, or parts of that, and found actually some sort of genetic correlate to being able to experience happiness and the genetic makeup. That's one. Related to that is synthetic biology. It's the use of engineering design principles and making principles to design and assembly biological components, or even, in the end, all kinds of mechanisms that could be self-replicating. It's a field that has a lot of medical promises, but there's also a lot of questions about it related to the ethical and security issues. A third one is neurotechnologies, technologies that intervene in our brain processes, either to repair or to improve our mental capacities. So think about, for example, deep brain stimulation, or selectively taking out certain parts of your memory. The US Army currently works on technologies that would take out certain traumatic experiences in soldiers who came back from war at home and now live very depressed lives because of everything they experienced. And the fourth category of technologies are artificial intelligence technologies, which I divide for the purpose of this talk in 2. On the one hand, there are technologies that come up with artificial agents that are self-propelled, that could make self-decisions, for example, about buying stocks or selling stocks. And secondly, interactive environments that respond to us, to our moods, for example. We are human, all too human, so we tend to forget things. We just postpone things that we should do. And we could think of interactive environments that help us do the things that we should do, that strengthen our willpower, so to say. Now, you may be skeptical, and you may think, well, that's all, fancy. There are so many technological problems to be solved. Yes, sure. But if you think of a time scale of 25 to 40 years, many things become possible. So I invite you to dream and dare. Let's assume that these technologies will deliver. What will happen? Now, it will certainly disrupt many things. It will disrupt our economy, our notion of work, our social institutions, our medical practices, our learning practices, our procreation, and so on. But most importantly, what will be changed here is us. We will become the object of design, not from scratch, but certain important properties of ourselves could be designed or could fundamentally be improved or changed. And that makes it a different ball game. Hence the title of my talk, which should have been already there. Thank you, Isolde. Homo novus, that means the new human being. For the new human being, the natural course of events is just one of the options available, and maybe not the most attractive option. Let's listen to the Australian philosopher Julian Savulescu. Marla, could you start the...
In favor of the natural. So if you look at the people who are against enhancing human beings. People like Michael Sandel, the German philosopher Jürgen Habermas, Leon Kass, Francis Fukuyama, all of them accept the use of science to treat disease, but they draw a bright line between disease and enhancing normal human beings. And many people have the same belief that we should leave, that there is something especially good about nature. And this is, I think, really a pre-scientific view of nature and the evolution of human beings. So this idea that we can look to nature to solve our problems is I think, deeply mistaken.
I think it's not the end of the movie, but anyway. So what he actually says later on in the movie, had it been shown, is that it is a pre-scientific view to just stick to nature, that we should think beyond that, and that we should think about really improving ourselves. And maybe we have a duty to improve ourselves in the light of all kinds of challenges that we have.
Maybe you can ask the people here who would actually do it. Who would green card, if it would be possible to have a cognitive device to improve, let's say, your memory. Green for who would do it, and red who wouldn't do it.
Okay.
I say 50-50, Antonio. What do you think? Okay, thank you.
So there's many green. Let me ask you a second question then, now that you're willing to change. Would you believe that those people who are in charge and have great responsibilities should mandatorily be obliged to have such a cognitive device? For example, the executive board of the universities, professors, politicians. So who would be in favor of mandatory use of these kind of devices? Well, that is rather... Okay. Before we move on, I think it's good to make a picture of what currently the situation is, what the Homo sapiens is. Well, the Homo sapiens, as we know, that's us. That's supposed to be a rational creature. We are not all the time rational, but at least we try to be. We have a certain autonomy and freedom. We strive towards happiness. We are embedded in social relationships, and we procreate in a natural way. Now, then later on in history, we became to see ourselves as part of the biological evolution. Culture is a very, very late development in the evolution. Now, you may have seen in the cursor last week that one of the persons in my group had discovered or found, together with people from Leiden University, that the two dominant explanations why culture happened in evolution turn out to be false. So why culture evolved is still a big question mark. But that's a side remark. Now, with this notion of Homo sapiens comes a certain notion of what it is to be a moral agent. Well, a moral agent is somebody who has certain autonomy and freedom, otherwise it would be a forced action. The ability to make plans, that seems important, and also to show goal-directed behavior. You should be able to understand the moral demands and options of the situation, to reason about that, to make a decision about that, and to act for good moral reasons. And in that, also to show empathy, to be able to put yourselves in the shoes of somebody who was affected by a certain action. That's the traditional picture. And this picture will be affected by these developments that I've mentioned. Now, related to this picture are three types of families of theories and ethics. One looks about the consequences of a certain action. And here the assumption is that we could oversee, in terms of time scale and magnitude, the consequences of an action. And these technological developments put that actually into question. A second family of theories are theories that look about the reasons, the moral reasons for an action, and the intentions by which such an action had been carried out. And it's all about respect for human dignity and autonomy. Now, if persons sort of become integrated with all kinds of technologies, what would be human dignity when somebody is a hybrid between technology and human. And then there's a third category family of ethical theories, and that is about the person actually who acts, being a virtuous person, being somebody who tells the truth, who is balanced in judgment, who cares, etc., etc. That also becomes a problem for such a theory once a human being becomes technologized. Well, let's see what happens due to these technologies. Well, all kinds of new technologies will be able to change our mental makeup. So there's a movie, Black Mirror. It's about the dark side of technology and humans. And it is about people who have an implant in their eyes and somewhere here, and that record everything that they experience in their life. The episode is called The Entire History of You. So from the very birth to your death, everything is being recorded. And you see in the movie the very strange things that happen if that is the case. So, for example, there's a hilarious scene where a couple comes home and they had a babysitter watching the baby. And what they do is they sit on the couch and they just rewind from the baby's perspective what happened in these hours that the babysitter was there and see when everything went okay. There's also a special office, a legal office, that could help people sue their parents if something went wrong in their raising up. And then what happens in the couple is that, well, she had a different relationship before him, and he's actually a very jealous person. And he knows that that other person still can see and experience and rewind and relive the sexual encounters that this person had with his own wife before. And he really becomes terrified by that, up to the point that really threatens him and attacks him and forces him to take out the device and erase all those memories. Well, the film ends when he himself puts out this device because he can't live with all that memories. So this is one.
Reminds me of the film Men in Black. Can I ask another question? Do you know these people that say that they're agents, and if you see a UFO, then they kind of erase a part of that memory. Green and red cards. If it's possible to erase something of your memory, it could be a trauma, as you were referring to at the start. A trauma. It could be possible. Who would actually use it? Erasing something like a trauma. Green cards, please, and in red if you would absolutely do not wish that this would be possible. Okay.
Actually, what strikes me is that so many people are not undecided about these issues. Okay. Well, the second category of technologies are about the human genome and the way that we can improve ourselves. And maybe we can try to start again a little movie with the Australian philosopher Julian Savulescu.
If I said, to you, look, take this vitamin and your child will be smarter, you take the vitamin. What's the difference between a vitamin and gene therapy? Both of them act on your biology. That's why they have an effect. The difference is two. One is that gene therapy is likely to be more risky, and secondly, it's passed on to the next generation.
Yes.
This is much more radical because you can, in principle, create any level of capacity or modification. With genetic selection, you're just limited by what a couple would naturally produce. All you're doing is selecting something that nature could have produced. Gene therapy, on the other hand, can produce beings which could never naturally exist. So it vastly increases the scope for human modification.
Would you enhance yourself?
Me?
Yeah?
Sure.
In what way? Maybe that's too personal a question, but...
I think that it would... some people have a high, what's called emotional intelligence. I don't think I have a particularly high emotional intelligence. I've learnt how to identify how people are feeling and to hope respond appropriately. But for some people it's very easy and they feel other people's emotions and react to those very quickly and intuitively. I don't think that I particularly have that, and I would prefer to understand other people's minds from that emotional perspective better, but I prefer to be smarter. I don't think there's any... I prefer to be more musical. A teacher stood me up in first grade and said, "You're tone deaf," and I never sung after that point. I mean, I would like to be able to appreciate what other people seem to appreciate in music. So, I mean, I have lots of limitations that
But you are a parent?
Yes.
And would you change something about your children?
I don't think I would change things about my children. All of my children, seem...
They're perfect already.
perfectly fine to me.
Okay, let's take questions. Who of you would change yourself with this kind of genetic techniques? And let me specify the question. So let's assume that you could have more experience of happiness and that there would be some sort of genetic modification that could help you to do that. Would you do that? Okay.
50-50. Can I ask you the question? What would you do when it comes to the amounts of moments of happiness, Antoni? Would you increase that with a pill or a device?
Well, I doubt whether I would do that. For several reasons, actually. Because, first of all, I think happiness is a contrast notion. So having a life with only happy moments seems to me very boring. But secondly, I think what's really underestimated in the story that we thought is that your genetic makeup is only one part of the story whether you will or will not actually experience happiness. A certain gene needs to come to an expression, or a set of genes need to come to expression. So it's also about what family you were raised, who your parents were, etc., etc. It's much more easy to experience happiness in a safe haven as the Netherlands than if you live in a war zone like Syria. So the genetic story is only part of it. Okay. Well, we skipped the thing about living longer because, I mean, there are all kinds of techniques that repair cells that are aging. Aging is a kind of disease, and that could also be cured, possibly, in the future. Let's now look not just at our own mental and physical makeup, biological makeup, but at how our environment would change due to all kinds of new technologies. Actually, this is about interaction. Now, there's not much interaction in the picture, actually, but these people may be interacting virtually with all kinds of people around the globe. Actually, we all ourselves are on email all the time, or whatever a medium is. So we have virtual communication all the time, but this is going to be extended. In the Human Technology Interaction Group, they currently work on virtual touch. And the holy grail is to be able to touch somebody in such a way that it becomes indistinguishable from a human touch. So imagine a care robot who's able to touch somebody at home in a way that for this person cannot be distinguished from a human touch. I think that would really change our emotional relation to the artificial world around us. Then, our relation to nature. There's very little nature in this picture. I mean, it's sort of the situation that most people in an urban environment are in, so it's sort of artificial nature. But studies have shown that nature and being in a natural environment is very important for regeneration. Not just for people who are ill, but also for healthy people. Now, given that there's so little nature around, what we will see is increasingly virtualized nature. So all kinds of visual inputs that simulates nature around us. And finally, our environment will become much more interactive. Well,
Yeah, technology is a very difficult part of
Technology
this
is a
show.
very difficult beast. So, okay, we'll become much more interactive. So it will respond to our emotional states, our needs, etc. It will also try to change our behavior in ways that are desirable from all kinds of view, from commercial kinds of points of view, from societal points of view, and so on and so forth. BMW is currently working on a dashboard in cars that responds to the emotional states of drivers. So if a driver is a little bit aggressive, it changes the music that is being played to the driver. If the driver gets bored and maybe sleepy, then they will change the music accordingly. So our environment becomes more interactive. And finally, the world will be populated by all kinds of creatures around us, creatures of our own making that are increasingly intelligent. Let's assume that these are two robots around us, humanoids. What I like about the left one is that a robot could also enjoy sunbathing. What will happen if robots, autonomous robots, being able to make decisions themselves, will populate the world? It's already starting. So I think Carlo will talk about autonomous cars. Autonomous cars, they will have to make decisions, also moral decisions. In a collision case, they will have to make a decision between either hitting maybe a child or an adult, or driving self against a tree, or whatever it is. So there are all kinds of decisions to be made. These artificial agents will change our life and our self-understanding, because we don't occupy this unique place in the world anymore, given all these creatures around us, and given that we ourselves have become the object of design. Now, so the important question underlying everything is, this is a variation of the old philosophical question, what is a human being? The question now transforms into the question, what should a human being be like in the future? What sort of human being do we want to become? And I invite you to think about this question. Now, 25 to 40 years ahead, we will see a lot of disruption. We will see that the mental makeup, the physical makeup, the biological makeup will change of ourselves. We will see that our body becomes more technological. We will also see that our environment becomes responsive and that our world will be populated by all kinds of intelligent creatures. And that means that when it comes to technological development, the slogan, let's make things better, changes to, let makes us better. And that also means something for the technological portfolio of the university. Now, what does it better actually means? And that's a hard question. In the English word progress, there is this idea of progressors, which is moving ahead. To what direction are we moving ahead? Well, when it comes to technology, there are virtually no limits. And that's fascinating about technology, actually. The only boundaries are the human imagination and the laws of nature. And in between, you can more or less make everything. So technology is not going to give us guidance in this question, which direction should we be heading to? And I think that is part of the mission of TUE as a university that understands itself as having a societal mission, that it should be part of this whole process of developing these technologies in a way that we can justify to ourselves and to our future generations. Well, the theme of this festival is Dream and Dare. Well, there's a lot to dream about when it comes to technology, but not all dreams are equally attractive. Some dreams may even turn out to be nightmares, such as this one. Thank you.
Thank you so much, Antoni. And then also the question for you, we're here together now, just before the break, 1 minute please. It's 2056, and we're celebrating the 100th anniversary. What do you see? How many people are humans? How many are Chinese, female? What do you see?
Well, I think at least one will be a robot giving a talk. Maybe not my talk, but maybe a different one. So that's one thing. And
actually, here are the heroes of the Technical University. Amigo is not here, but we already have like non-human heroes at the TU. So you think that's going to be a role for?
Yeah, but
either
that's far removed from giving a talk, right?
Yeah.
So I also think that I'm not sure that we will convene in a physical place. So maybe the university is much more distributed, and we will celebrate this event in 2056 virtually.
Yeah.
And there will be a lot more Chinese people around here. I mean, like your dress shows already.
Yeah. I was thinking of that too. Okay, thank you so much.
Okay.
Tony Meyer, thanks. I have one thing to say. There is a break. After that, we're going to talk about smart mobility. If you have any questions, use the hashtag. So I can ask Carlo anything about smart mobility, because he knows about that. And also, what are universities for? Bert Meijer is going to talk on that. So if you have ideas, use the hashtag. And I only want to say, I see you back in 20 minutes. And I asked the band to start playing again, so you know we're going to continue. And use this exit, because all the drinks are here. And see you back in 20 minutes. And thanks for the first speaker. Thank you so much. Power to the people!